All right, welcome to section 1.5, which is analyzing graphs of functions. We're going to start out today by going back through the three definitions that we did before in section 1.4. As we go through, again, the biggest thing, you must know these definitions in order to be able to answer questions that are coming up. First and foremost, the domain, if we go back, was the set of all x values. Let me try and spell correctly. The set of all x values. Okay. Range was the set of all y values. And let me just make sure that we're okay too with what that also, another word we used, domain, they also talked about inputs, and I want to make sure you know that word. And range, they also talked about calling them outputs. Okay, so we'll make sure that we have those in the definition as well. And function, we said, was the most important. How do you determine if something's a function? We're looking at the fact that for every x value, there is exactly one y value. Okay, so for every x value, there is exactly one y value. You could interchange that with inputs and outputs as well, but that's kind of the idea of the three big definitions from section 1.4. This boxed in area is the new material. It's not that you haven't done it before, but we're looking at this a little bit differently in pre-calc than we did in Algebra 2. One thing we want to talk about is if we talk about domain and range, or increasing and decreasing, we want to talk about the endpoints of an interval. And if you want to include them, there's the big word, if you want to include the endpoints, we're going to use brackets. Okay, if we want to include the endpoints, then we're going to use brackets. It's like the same thing as if I had on a number line and I said this was included and this was included, where we used closed circles. It's the same idea, it's endpoints. If you don't want to include, so to not include, then we're going to use parentheses. And again, as you're talking on a number line, that's exactly the same thing as if this were an open circle and this were an open circle. It's that idea. Open circles are like parentheses, closed circles are the brackets. Now, when you talk about infinity or negative infinity, we don't know an exact end number for infinity or negative infinity, and so we use parentheses. And it's because we don't exactly know what that last number is that we use the parentheses. And so what I'm going to do is help you kind of see on one example how that works. Now we ask you to plot these points right here. So we're going to take a second and plot these. -1, 1, 0, 3, 1, 0, 2, -3, 4, 0, and 5, 2, they say is an open circle. And what you want to do then is connect these. It makes kind of a curved shape. Okay, so we want to look at this. Now, given this graph, we're going to start talking about domain, and domain is the x values. The lowest x value we have is here at -1. And because I actually have a point at -1, I'm going to put a bracket. And then the farmost x value, the x value to the right the most, is at 5. And so at 5, since it's an open circle, it's saying not included, so we're going to put a parentheses. Okay, for range, we're talking again the y value. And so the lowest y I have is at -3, and it's included. So at -3, I'm going to put brackets. And the highest y value I have is at 3, and that's also a dot, and so that's included, so it's a +3, and then I use a bracket again. Okay, and again, it's because they're actual dots. If it's an open circle, then you'd say not included. Now the question is this a function? For this x value at -1, do I only have one y value? Yes. At this x value of 0, do I only have one y value? Yes, -3. And as you look at this, you're looking at this. Do I have any duplicates in the x value which give me different y values? And if the answer is no, then it's a function. Okay, and the way I would say it is because for every x, there is exactly, I'm going to say equals 1y. We're going to shorthand this a little bit. For every x equals 1y. And the idea is basically, I don't have an x that maps me like this point and a point up here. That's when you have the issue. Like if this x gives you two different y's, then there's a problem. Okay, so the next thing we're looking at is zeros. Zeros are the same thing as x-intercepts. Okay, so if I'm looking at x-intercepts, I have an x-intercept at 1, and I have an x-intercept at 4. We would like you to write these as points, and the way I kind of make sure I know they're points and not intervals is I say point right in front, and then I say 1, 0. And then I have another point at 4, 0. You do not have to include this point part, you don't, but for me it then says, okay, I know it's a point and not an interval, okay? The next part we're looking at is increasing or decreasing. This is a range of values. It's not a specific one to a specific one, it's a range of values. And increasing and decreasing always use parentheses because I don't care about the endpoints. You're not increasing or decreasing at an endpoint, you're increasing or decreasing between points. And so that's the idea as we go through. So I'm going to look at this. Let's talk about increasing. It increases from here to here. It's going up from left to right. So it's an x value. Use these with x values. Okay, and as this x value, it goes from -1 to 0. And again, I'm using parentheses because I'm only looking at the interval between these. At this point, it's not increasing, and at this point, it's not increasing. It increases between them. The second interval it increases is this interval here from 2 to 5. Okay, so second interval from 2 to 5. The next question asks decreasing. It's going to decrease everywhere else if it's not increasing. And so you're looking at it from here to here, it decreases. And that's from 0 to the x value of 2. So from 0 to 2. And you'll notice as I look at this, doesn't it actually look like a point? And it's not, it's an interval. And so that's why I write this point here, so I know the difference between the two because there needs to be a difference. Okay? Relative maximums and minimums are basically the highest or the lowest point that you can see. If you can't give me an exact point of a maximum or minimum, then then you don't use it. Here, if I look at my maximum, this seems to be the highest that this graph goes. So this is the point, and again, I'm going to use it like this. This is the point 0.3. And again, I'm going to put point there so I know it's not an interval, it's an actual point. The minimum looks to be this point down here, which is 2, -3. So I'm going to say point to -3, okay? You will be given some sort of function graph, something like this on the quiz, and you will be asked to answer all of these questions. And so please, as we go through tomorrow in class, if you have questions about why this works or how come this is a point and this is an interval, please make sure you ask. I'm actually going to skip the notation at the bottom. This can be found, let me slide it down for you. This can be found, all of this notation comes directly right here from your book. So what I would like you to do is take it from your book and fill it in. And what we will do tomorrow then is actually compare answers and talk about then What does it mean to be constant? And what is a relative maximum or a relative minimum? And you've kind of seen that above, but I want to be looking at those type of things. And truthfully, the best way to do it is to have you look at it and then have a discussion tomorrow morning in class. Okay? So let's flip to the back side. We're going to ask you to find zeros algebraically. That doesn't mean go to your calculator and look. That's how we're going to check it. And so if I want to find the zeros, we're going to start off in this first one. I have a quadratic, an x squared, 13x, and a 6. This is a quadratic. And as I'm looking at it, in order to find the zeros of a quadratic, I have to factor. Okay? Now, I don't care which method you use for factoring, and maybe that's something we have to talk about tomorrow. You have a couple of options. You could guess and check. You could use the SNP method with the table, if you remember that. But we're going to spend some time tomorrow factoring. But what ends up happening is if I factor this into two binomials, I get 5x plus 3 and x plus 2. And I'm going to set this equal to 0 in order to find the zeros. Well, if I set this first group equal to 0, and I solve, I get that x is negative 3/5. So this is the first 0, and we're going to write them as points in just a minute. The second one, if I set it x plus 2 equal to 0, I should get that x is negative 2. And if you're unsure on any of this, please tomorrow ask questions. How did you get this? Anything like that. So basically, our two zeros I'm going to write as points. Negative 3/5 0 is 1 point, and negative 2 0 is the second point. Let me erase that little extra line I have there. Make that a 0. Okay? We'd like you to write your zeros as coordinate points. If you want, again, you could say point to kind of make sure you know. Sorry. But as you're going through, again, zeros are points. In this case, if you have a quadratic, the only way to go for zeros, well, not the only way, is to factor is the quickest way, or you could do quadratic formula. Okay? The second thing in order to find zeros, if I square root, I'm going to set this, let me just put it this way. I'm going to set this equal to 0. Because if I square root 0, I just get 0, so I don't need the square root. All right, so I'm going to go through and solve. I'm going to move the x squared over. 9 equals x squared. And if I square root, I get that x is a positive or a negative 3. Please do not forget, every time you square root, you should get 2 answers. Okay, so my two zeros then are the point 3, 0 and the point negative 3, 0. And again, if you wanted to set the square root equal, you'd find out you don't really need to, but that's fine as well. So going through, we've looked at two types, one where you factor and one where you just set it equal to 0 and solve. And we'll do a couple more of them tomorrow as we look at our homework. This average rate of change, circle star at something like this, you actually already know how to do it. We've just never done it with quadratics. Average rate of change is exactly the same thing as slope. Okay, average rate of change is the same thing as slope. We're looking at the slope at a specific point. And so the definition your book gives you for rate of change is if I take f of x2 minus f of x1 all divided by x2 minus x1. Now, f of x is the same thing as y. So really this is y2 minus y1 over x2 minus x1. Guess what? It's slope. The only thing that's different in rate of change is we don't give you the y values. So I need to find the y values. If x equals 0, I'm going to plug that in my function. 0 squared then is 0, so I have a point 0, 0 to work with. If I plug in the x value of 2, then 2 squared is 4, so I have the point 2, 4. Now, given my 2 points, I'm really just going to find the average rate of change or the slope. So 4 minus 0 over 2 minus 0 is 4 over 2, or just 2. Okay, now this will get harder. Please understand that. This is the most basic idea of it. But what I want to do is I want to look at this and basically say, listen, it's just slope, guys. The only problem is I don't give you the y values. We only give you the x values. And so you have to basically plug things in order to get the y values. And then once you have your points, then you do slope. Okay, and so that's the idea. And so that's the whole idea of the new content that we have for today. Here's what I would like you to do for tonight. The video is much shorter than normal. And so what I want is this last section I would like you to do for tomorrow. And we're going to start off the day going through these. So do tomorrow. If you can read that, sorry. This is what I want you to do. And you have the notes from above to kind of check it. Biggest thing, we are going to ask you things about interval notation. So do you need the parentheses or the brackets? But please use your calculator. You can use your calculator to graph this. But I want to start off tomorrow just going through this example. Okay? If you have questions, please circle them. Let's say I don't really know quite that well what a relative maximum or minimum is. Please circle that. What I am asking, though, is that you make an attempt on every question. This even or odd one, we're going to do together. Okay? So this even and odd one, we will do tomorrow in class. The rest of them, though, I want you to do for tomorrow. Thank you for watching the video, and we will see you in class.